Hey guys, this is video 10.4. We're going to be talking about the ideal gas law today. Before we even get started, make sure you have a calculator and have your reference tables out. I want you to, before we get started, go ahead and flip to table T, the formula page. This is not a law that's actually given to you, but it's one that could come in handy and help you with some things, some questions you might see. So we're going to write it in there. It's one that I would encourage you guys to memorize. There's a song that can actually help you with that, so you can check that out in the classroom and on my YouTube channel to help you kind of memorize that. So we're going to be on page 10 in your packet. I call these next ones the advanced ones just because there's some extra steps maybe that we have to do here versus the basic ones, and those are just converting to the proper units and remembering those proper units. So what I want you guys to do on table T in your reference table right now, write down this formula, PV equals nRT. This is an important formula that really helps us out. Now, this is based on that ideal gas, but we know that, gases don't behave ideally at all. And this is something that will help us to kind of figure out pressure, volume, number of moles, particles, all that kind of stuff. So this is kind of going along the lines of Avogadro's law, and you'll actually be able to go back and finish back here on page number 5, I believe, 4, page 4. These last two questions after we do this. So you'll be able to use the quantities here in this table to kind of answer those last two questions. All right, so that's something that the ideal gas law really helps us do when things aren't at ideal conditions, which is pretty much all the time. So make sure that you, as you're going through and working these problems out, I would encourage you guys to not only write PV equals nRT, but define what the variables are, just like table T does with your other formulas. P has to be in atmospheres, volume has to be in liters, temperature has to be in Kelvin, N equals moles, and then R is this gas constant. Memorize this number, okay? 0.0821 latum over molk. Now I say latum over molk because it's liters times atmospheres divided by moles times Kelvin. And that's why we have to have atmospheres for pressure. That's why we have to have liters for volume. That's why we have to have Kelvin for temperature, is because of that R, that gas constant right there. Okay, but other than that, making sure we have those right units, the rest is pretty easy once we have those, because we're going to be given 4 of the 5 variables, and we're going to be solving for the unknown. Okay, so let's kind of dive right in. Again, being organized is key. You're going to see me work all my problems out, like I've said before, by writing down all my variables. So what's the pressure? We're looking for P exerted by a 12-gram sample, so that's going to be a mass. Okay, 12-gram sample of nitrogen gas. Notice, guys, remember, you have to remember Brinkelhoff. Get in the habit of, whenever you're doing any practice sheet from here on out the rest of the school year, write Brinkelhoff in there so that you remember, hey, if I have one of these elements by themselves, they exist in the diatomic state, because that's going to change their molar mass, which will then change their number of moles. Speaking of moles, notice how, oh, this is grams. We need to get it into moles. So how do we go from grams to moles? This is a review. If you can't figure this out, then you got to go back and review. Look at your unit 6. 2, 3, 4, 5. Yeah, no. I'm sorry, unit 3. It used to be unit 6. Your unit 3 notes with the mole roadmap, okay? You've got to be able to do this. It's a one-step conversion problem. Divide by the molar mass, which in this case is going to be 28 grams, 1 mole. And then when you do that math, guys, you should get 0.43 moles. Now, we're also given a volume, which is 10 liters. We're given a temperature, 25 degrees Celsius. We need to convert that right away to Kelvin, so 298 Kelvin. And then my R value is that constant, 0.0821 latum over molk. Now it's just plug and chug. PV equals nRT. Got to get P by itself, so I'm going to divide by V. So P equals nRT divided by V. My N is going to be 0.43 moles. My R, 0.0821 latum, liters times atmospheres, divided by molk, moles times Kelvin. I know it's hard for me to write that in so small. 298 Kelvin divided by my volume, which is 10.0 liters. So liters are going to cancel out, top and bottom of a fraction. Moles and bottom of that fraction, top here. Kelvin will cancel out. So we're left with atmospheres, which is a good pressure unit. So make sure your units cancel each other out. When you do this math, guys, top times top times top, divide by bottom, you should end up with 1.05 ATM. Remember, sig figs only if they ask you for sig figs. All right. If we were going to report it to proper sig figs, it would be 2 because of our temperature, but again, it doesn't matter. So pause this video, try this other U-try problem, and then move on to video 10.5. All right, so here we go. We're going to figure out moles in this problem. How many moles of gas do I have? So that's my N value. Pressure equals 121.6 kPa. What do we have to do with that right away? We got to get that to, we got to get that to atmospheres. So we've got to divide this by 101.3. If you didn't do that, your answer's wrong. Okay, because again, it goes back to our R value. R equals 0.0821 liters times atmospheres. Atmospheres have to be our pressure unit. Divided by moles times Kelvin. Okay, so when you convert that, 121.6 kPa equals 1.2 ATM. R value's there. I've got volume of 31 liters, and my temperature is 87 degrees Celsius. Add 273 to that, we end up with 360 Kelvin. So our formula, guys, is PV equals nRT. We need to get N by itself, so we divide by R and T on both sides. Those are gone there. N equals PV over RT. Now it's just plug and chug. 1.2 atmospheres times, 31 liters. Divided by 0.0821, multiplied by my temperature, which is 360. When I do all that math, you should end up with 1.26 moles for your answer. All right? So go on to video 10.5 before you go on to practice 3, because what we're going to use in 10.5 will also be on your practice number 3.